In this video, I'm going to show that if a function has derivative 0 for all x in the interval, open interval ab, then the function is a constant function in that interval. We show that by showing that two different values of x gives you the same function value. So that is to say, if you have two values of x, so input value x1, x sub 1 and x sub 2, and for simplicity assume that x sub 1 is less than x sub 2, then if somehow we can show that f of x sub 1 is actually equal to f of x sub 2, then we just essentially showed that the function is a constant function. That means it does not change. Okay, if you vary the input, if you change the input values, it doesn't change. So let's assume the following. So look, consider the interval x1 comma x2. Okay, this is, by the way, contained in this interval because x1 and x2 has to come from a comma b. So technically this is a subset of a comma b. Now the function f is differentiable on ab, so that means that since x1 and x2 contained in ab, it must be the case that x sub 1 comma x sub 2, the closed interval, in this interval f continuous. F is continuous. Number 2, it must be differentiable. F is differentiable on what? Open interval x1, x sub 1 comma x sub 2. So these are the two preconditions for the mean value theorem. So since these two are satisfied, by applying the mean value theorem, we can conclude the following. F of x sub 2 minus f of x sub 1 divided by x sub 2 minus x sub 1 must be equal to f prime of c, where c is in the open interval x sub 1 comma x sub 2. However, it is given that the derivative of f regardless of the input value is always 0. So f prime of c must be 0. So this in essence tells me that this left hand side is equal to 0. So we have f of x sub 2 minus f of x sub 1 divided by x sub 2 minus x sub 1 is equal to 0. Now x sub 2 minus x sub 1 is non-zero because x sub 2 is greater than x sub 1. As a matter of fact, we can go ahead and say that it's a positive number. So if I multiply both sides by x sub 2 minus x sub 1, so multiply both sides by x sub 2 minus x sub 1, so times x sub 2 minus x sub 1, and let me put a parenthesis here just to distinguish things. Then I have this and this cancel out. That gives me f of x sub 2 minus f of x sub 1 must be equal to 0. That tells me f of x sub 2 is equal to f of x sub 1. That is to say, f of x sub 1 and f of x sub 2 are both equal. However, these x1 and x2 are some arbitrary points in that interval. So it could be anything. So therefore, we just showed that for any point, okay, for any point in this interval a comma b, okay, I meant to say any 2 points, any 2 different points in this interval a comma b, f of x sub 1 must be equal to f of x sub 2. That means it says that the function is constant. Okay, function is constant in that interval because the function value does not change whatever input you give it. I hope that this discussion was helpful. Thank you very much.